Welcome to virtual class.
So when you're modeling fraction multiplication, there's a couple of different methods. By the way, this is only one option of one way to visualize it. So it's useful to be able to recognize these and then know, oh, I can use my multiplication trick. Or if you're asked to model something, this gives you an option. So there's the fraction strip way where you take 2/3, you divide it evenly, just like they describe here on 9.5. Some people know fraction strips. I kind of prefer the area method, which I'm about to explain now. So the idea with the area method goes like this. You've got two fractions. So you got 5/8 and you're supposed to multiply that by 2/3. Well, how you do that is you set up your 5/8. So if I just block out the bottom part here, you can see how these are um, uh, 8 slices of a rectangle, or at least of a line, right? So you take a rectangle and you slice it vertically, right? And that's going to be one of your fractions, and you can color those in. So in this case, if I'm only looking at this much, you can see there are 5 out of a possible 8 are filled in. So that's your 5/8, right? Now, the other way, horizontal cuts, are your other fractions. So you can slice it into, so again, if I cover up all of that, you can see that that is 2/3, right? So it's just 2/3, except it's stretched out over the whole thing. So two of those three are colored in, and the last one is uncolored. And then what you end up with is the parts that where they are overlapping right there. That's your resulting fraction. Now, that's not going to be simplified though. So once you've got your answer, 10 out of over 24, then you do still have to reduce it. But that's the way, one way you can model it. Now, if you would rather just do the multiplying across thing, that's totally fine too. So when you're doing fractions with multiplication, you can just take your product and multiply across. So I'm going to see if the document camera is working and just walk you through that one more time. It does not appear to be working. Activate? Activate? Hey, hey there. Okay, cool. So let's take a look at this on the document camera. Name it down where we're looking. And I'll get you a fresh page. So let's just do standard multiplication. We'll do 3 over 4 times 1/3. Sorry, denied. If anybody needs in, just remember you always have to use your student account. All right. Sorry, just getting a knock on the virtual room door and I'm not opening it. All right, so one of the things you can do with this is just to rewrite it. And we've talked about this before. You can just type uh, rewrite it as 3 times 1. You multiply the numerators and you multiply the denominators. 4 times 3. You multiply across like that and you get 3 on the top. 3 times 1, and 4 times 3 is 12. Now, I would have to reduce that. It's currently not reduced, so I'd need to reduce it. So I can pull a factor of 3, and so I get 1 3 out of there, and I get 4 3s out of there. So my final answer is 1 over 4. Now, there's also this neat trick where if you don't want to end up reducing later, like we did here, you can actually reduce before. And I'm just going to remind you of that. To reduce before, you look at your multiplication question and you look for a factor that you can pull out of both sides. Now, here's the trick. You can reduce up and down. So if I had, let's say, this had a factor and this had a factor that I could reduce, I can reduce up and down. Cool? So up and down. Do this with me. Up and down. It's like football uprights. Yeah, that's good. Now I can also reduce on the diagonal. That's totally fine. So reducing on the diagonal, yeah. I know it seems a bit weird, but yes, you can do this, okay? But you cannot reduce on the horizontal. No, no, no. Okay, so yes, yes, no. Do it with me now. Yes, yes, no. All right. So that's the way to kind of remember how you are allowed to reduce before, and you're not allowed to reduce horizontal. Cool? So when I look at this question, I can look for a factor on the vertical or diagonal. 1 and 4 doesn't help me. 3 and 3, hey, that helps me. Pull a factor out of 3 out of that, and a factor of 3 out of that. So literally, I can actually save myself the trouble by reducing before. So 1 times 1 is 1, 4 times 1 is 4, and look at that. It's the same result as if we had reduced after. Now, either way is fine. You can multiply across and then reduce. So that's the reduce after. Or you can reduce before using these rules. So either way is totally fine. Cool? So that's for multiplying fractions. Now we're going to just do another sample where I'm going to model. So let's say I have to model 2/3 times uh, 1/4. Okay? So let's say I have to model this. Well, I could do fraction strips and do 2/3 and then slice it into quarters and take only one of those. That would look something like this. Whereas if I've got a fraction strip and I've got thirds, and then I've got two of them, so I'm just going to color it in two of them. All right? This is like the fraction strip method. And then of that two, I can kind of extend that down to, I now have a new kind of fraction strip here, and I'd have to divide it into quarters, right? And I've only got one of those. So what I would end up with is something that is that size, and I'd have to figure out how many slices that is of the total. Does that make sense? So that's kind of the fraction strip method. I'm okay with that, but I actually prefer this method, which is using the area. So it's the area of a rectangle. So let me just draw that in here. So if I'm asked to model the fraction multiplication, I can get myself a rectangle going over here. And then I look at the denominators and I say to myself, okay, well, I need 3 slices and I need 4 slices. So I pick either vertical or horizontal. I'm going to do 4 on the vertical. It doesn't really matter. I just choose 4 because I find it's easier to do more frequent one, like more cuts vertically, but it doesn't really make much difference. And then on the horizontal, so that's 4. So this is cut into fourths, right? And out of those, I only have one of them. So we'll shade that in. I'm just gonna use my pencil to shade in 1/4. So you can see that that is 1/4. Make sense? Now, I need to do the other cut though, because I'm multiplying, which is kind of overlaying. So I now need thirds. I look at my denominator and I need thirds. So I need thirds. So I'm going to just put little tick marks to show my starts. If they look good, great. Then I can get my ruler or pencil or straight edge and go across like that. And oh, I kind of made a mistake. That's all right. Now I've chopped the whole thing into thirds, right? So now it's into thirds. And out of those thirds, I've only got 2 of them. So I'm going to need to go into uh, a different color in this case, just to make it clearer. I need 2/3. I'm going to color it in with this. So I end up with this piece and this piece. So if I do 2/3 of 1/4, then these are the only pieces that I have. Now it's just a matter of taking a close look at this area rectangle and figuring out how many squares I have in total, and that would be my denominator. So I do a quick count. So 1, 2, 3, 4, 5. Well, you can do multiplication. 3 times 4 is 12, right? So there's a total of 12 squares here. And out of those, only 2 of those are now are colored in by both the pencil, the gray, and the yellow. So the gray was the fourths, and the yellow was the thirds. So I only have 2 where it's both. So I'd end up with 2/12. Now I'm going to want to reduce that as well as soon as I see, oh, 2/12, I can divide that both by 2, which would equal 1/6 of the entire piece. Now I can check my answer using the algebra way. So let's do that real fast. 2/3 times 1 over 4. So you don't have to rewrite this every time. I like to, but you don't have to. So 2 times 1. I just like to show you where it's coming from. But you can kind of skip this step if you want to. 2 times 1 is 2. 3 times 4 is 12. And then I would have to reduce it down to 1/6. So that is correct. And again, if I wanted to, I could reduce before if I kind of pretend this part didn't happen. And I look for a common factor using those rules. Vertical, diagonal, not horizontal. So I go vertical, no, vertical, no. Diagonal, no. Diagonal, hey, I can pull out a factor of 2 here. So that would just be 1, 2. And that's real easy math. 1 times 1 is 1. And 3 times 2 is 6. So there we go. We have our answer. Cool. A couple different ways to see it, calculate, and check it. So that was our check. I hope that's clear as mud. You are welcome to dive in and just begin using these techniques to solve 9.5, which is right here on the Google Classroom. So go ahead, and I've posted the questions. I believe it was 4, 5, 6, 9, 10, 15, 17, 18, 20. Right here. All right, and if you need any of this refreshed, or if you want to see yet another way to figure out how to do these, don't forget to check out those Math Antics videos, all right, because they are very useful at walking you through some of these kinds of tricks and tips. They don't necessarily show you all of the ways, but that's my job. All right, I hope this is clear as mud, and in a second we'll do the next thing, which is our DJ queue. So we're going to be taking up 9.1 and 9.2 as a live DJ queue, and if you have any questions, type them in chat, unmute on the microphone, or hit me up in the comments section of any of the Google Classroom. All right? Thanks.